Okay, let's talk about u substitution. How about this question? X times square root of 2x minus 1 dx. Now, if you want to solve this question, there are actually two different ways to do the u substitution. Some people would take 2x minus 1 as u. Some would take the square root, the entire thing, as u. And you can compare both methods, but usually when you have the square root, it's wiser to take the entire thing and take it as u. So I want to show you how this is done. Set u equals the square root of 2x minus 1. And by the way, you may not have done this type of u subs in calculus 2 because I noticed that some of you only did the most easiest u subs. So for some of you, it may be the first time you're seeing such a u substitution. You'll understand why this is tougher than the usual one pretty soon. Okay. All right. So let's see. If I differentiate du, the derivative of square root of x is what? 1 over 2 radical x, right? And because of that, this is 1 over 2 times square root of 2x minus 1. And then by the chain rule, the 2x minus 1 has to be pulled out and you have to differentiate it, which gives you 2 times dx. And the 2 and 2 cancels. And that's it. So you get, if you solve for dx, you get dx equal to square root of 2x minus 1 times du. Okay. So that's step 1, right? How do you do u substitution? First, figure out what to put as u. And sometimes there's more than one way to do it. Sometimes there are more than one valid thing to put as u. You could have taken u to be 2x minus 1 and you could have gotten the answer. It's just that if you include square roots, sometimes it's easier. Okay. And then step 2 is you differentiate it and say du is the derivative of whatever you substitute it with times dx, and you solve this for dx. That's the second step. Okay. And then the third step is, well, if this wasn't a definite integral, should I do that? 5. Yeah, let's try a definite integral because you need definite integrals. So let's try this one. Definite integral, 1 through 5. So in the case of definite integral, not only you have to change the x into u, but you should also change these values into the value of u because see, this is what we're trying to do. We're trying to make this is x, I don't know what to do with it, but this is u, and then dx is same as that, so it's square root of 2x minus 1 times du. And look at this one, because we have du, the values here should be the value of u. Okay? So you can't use 1 and 5 there. You have to think about what value u would be if you were to have x as 1 and x as 5. Okay? You have a question?
Oh, no.
All right. So, okay. So if x is 1, what's the value of u? If you plug in 1, 2 times square root of 1, which is 1, right? So that didn't change by coincidence. Usually it changes. Now, if x is 5, what's the value of u?
3.
5 times 2 is 10. 10 minus 1 is 9. Square root of 9 is 3. So 3 goes here. Okay? And that step is something that a lot of you didn't learn, or maybe you learned it, but you didn't use that much, because sometimes people leave this as x and then go back to x, and there's some other ways. It's more lengthy. I don't like that. Okay, so try doing it this way. Okay, change the endpoints. Okay, now let's think about what to do. When you're doing the u subs, you have to make sure that everything is written in terms of u. You can't proceed with the integration if you still have some x's laying around. Okay? This one I know what to do. What is this?
Sorry, what?
What is square root of 2x minus 1 in terms of u?
It's you.
It's just u. Square root of 2x minus 1 is actually u. So that one I don't have to think too much. But then this x, what do we do with this x? And that's where a lot of you didn't. I mean, for some of you, I think this is the first time you see such a thing. What do you do if you still have an x there and it didn't go away? Yes?
No, I just got a question. I thought like u sub was like the u times v minus the integral.
No, that's called integration by parts.
Oh, yeah.
Do you set another, like a w value or something?
Why
No.
do you have 2 u's?
Huh?
Why do you have 2 u's?
Oh, because this is equal to u.
Times u.
This is u, that's u, so u times u.
Yeah.
But my question is, what do we do with this x? What do you do? Yes?
Wouldn't, when you do the u sub, when you solve for du, wouldn't that have to cancel or something like that?
That's what I'm saying. A lot of you only did the case where everything cancels and it just has only u at the end of the day. But this one, sometimes you may have some extra x's lying around.
It's a constant, right?
No, it's not. It's not a constant.
Do you
No.
solve for du?
No. The key is to solve this for x. Okay?
Oh.
So you solve this for x. Let's see, what is that? That's u squared is equal to 2x minus 1, right? U squared plus 1 is 2x. So x is u squared plus 1 over 2. Okay? That's this extra process you have to do. And certainly these types of integrals do appear in differential equations, so you should know how to do these. Okay? Let's see. So what are we getting? It's 1, 2, 3 u squared plus 1 over 2 u squared du. And then this 1/2 can be pulled out, and you're trying to integrate 1 to 3 u squared plus 1 times u squared du, which is 1 to 3. U squared times u squared is u to the 4th. 1 times u squared is u squared du. And now you integrate each one of them. How do you integrate these things? You add 1 to the exponent. That's the power rule, right?
Yeah.
So 5, and you put the reciprocal of this number in front, which is 1/5, right? And then u squared, you add 1 to 2, which is 3. You put the reciprocal of this number in front, which is 1/3. And then you plug in 3 and 1. What? Where? What? What did you ask?
No, I was joking.
Okay, okay. So you have 243 over 5 plus 9. 45, 243 plus 45, that's 288 over 5. So it's 144 over 5 after dividing by 2. That's what you get if you divide if you plug in 3. And then when you plug in 1, that's 8 over 15, 4 over 15. So minus 4 over 15. This part is not that interesting, so I just plugged in. You can verify that it's true. And if I multiply by 3, that's what's 3 times this? 2. 432, yeah. So 432. So that's 432 minus 4, 428 over 15. So that's the value of the integral. And I really wanted you to learn 2 things out of this demonstration. One is that you have to really change the bounds when you do the u substitution. Second thing is, if you still have some x's lying around, you can't proceed with the integration. You have to make sure that everything is in terms of u. Okay? And the way you do it is by going back and solving for u. Okay. Got it?
Can you solve it the other way?
What other way?
This is the only
Where
way?
you
I thought you
replug
said there's
in
a different way.
Where you replug in the U value.
Okay, well, that the other way. I didn't want to confuse you even more, but if you really insist, I can show you the other way.
Yeah, I prefer the other way. I like that's the way
No,
I-
no, please don't.
No?
Please don't do it that way. You should do it this way.
You're not legally wrong.
So I'll just sketch what I meant by the other way. See, it's still the same thing. You still need to do. You still need to write down u squared plus 1 over 2 u squared du. And when you write these values, you have to say x equal to 1 and x equal to 5. Okay? Don't write 1 and 5 by themselves, because I'm going to take points off if you do that. Okay? Because you didn't change the values to 1 and 3, you better put x equal to 1 and x equal to 5. All right? So when you integrate this, what are we getting? It's the same integral. You get 1/2. 1/5 of u to the 5th plus 1/3 of u to the 3rd. And then you're trying to plug in x equal to 1 and x equal to 5. And because these are values of x, you can't plug these into u. Okay? So what do you have to do?
Plug U back
You
in.
have to go back and write down square root of 2x minus 1 to the 5th power plus 1/3 square root of 2x minus 1 to the 3rd power, and now 1 and 5 can be plugged in, and afterwards it's the same thing. Okay? No, it's not. Okay, well, I mean, if you really do get the right answer, I have no choice. I'll give you full credit. Okay? But
I think that's how a lot of us are taught it.
Yeah,
I think that's why.
yeah, but that's the wrong way. And you know what happens in most cases is that people forget that these are values for for x, and they just plug these into u and get the wrong answer. That's how you don't get the full credit. Okay, so don't make that mistake. I'm okay with doing it like this. Make sure you do it correctly though. Okay, if you get it wrong, it's on you. The blame's on you. Okay.